Okay, so we're on chapter 2, starting it up. 2122. This is a little bit of a mixture. Some of these problems are actually 2.2 stuff. The one with the decimals is a 2.2 homework question. The only time you'll get to use decimals is when the directions say give your answer rounded to the nearest whatever decimal value. Continue on with 2.2 on Monday, sort of some 2.3. 2.3 is dealing with square roots. Make sure we know how to simplify square roots, deal with imaginary numbers. There's a lot going on in 2.3. Wednesday, 2324, and we'll take a quiz on 2122. Chapter 1 bonus problems. Started this morning. You have from today, this morning, until next Wednesday, office hours only. If you saw my announcement last night that I posted, some clues as to what to expect. 8 problems, 4 points apiece, max out of 32-point bonus question. So if that's 32 points on top of the 124 possible, that would be a 156 out of 124 if you have everything right on the test on the phone. Speaking of the test, they're not done. Well, I haven't even started yet. Yeah, I'm giving quizzes, 2 quizzes. You don't care. But I've got all your tests, Tuesday, Thursdays, and I've got, okay. So I just slam myself with a bunch of work, which you'll get it back on Monday. But the last day to drop class, an 18-week class, is Friday. So some of you might think you have a decision to make. I can't make that decision for you. Some of you might want to ask, can I still pass the class? I can't tell you yes or no. I won't tell you yes or no. Because that's not up to me. It's up to you. I drop your lowest 2 quiz scores. I replace the final. Final replaces your lowest test score because the final's higher. So there are things in place if you have bad dates. But we have at least 3 more tests in the final. The test was like the review sheet, right? Yeah, no, it wasn't. So if you prepare for that review sheet, so you know what to expect. I can't spell it out. I could, but I think I did. Anyway. If you need to know what your overall grade is, as of right now, it's just your quiz scores. That's the only thing that's been graded. That's the only thing that's in there is your quiz scores. The 3 quizzes. Okay, the 3 quizzes. Exponents. That quiz on 1.2 and the quiz on 1.3. Now, what happens after, and the quizzes are only 18% of your grade. Test is 64% of your grade. Okay. Homework's 18%. How you scored your homework. And then I come around and I'm going to score how you scored your homework. So you have control over a lot of things. Okay, so decisions you need to make. I don't want to lose anybody. Because if you have to pass this class, if you need this class in terms of general ed or whatever, you want to move on. You've taken that. Why not, regardless of whatever your grade is, it's not about the grade, it's what are you going to absorb that even if you have to take it again, quitting means you're not going to get anywhere. You'll start over back at 0 instead of at least have a foundation to build upon. And there's nothing wrong with having to do it more than once because sometimes the foundation isn't there. I don't know everybody's math background, or I don't know everybody's emotional frustration sometimes with math. Math brings a lot of angry emotions with it sometimes. I've seen it. People yell at me in partners. I hated my math teacher. You know, they tell me about their whole life experience with math. So, you know, I need to make a false career. I need something like that. I've taken other people's guns for living. But you have to figure out what you're going to do. One of my smartest friends I have, they took him seven semesters to get through Algebra 1 at Federal City College. Back in the 80s, you could take it as many times as you wanted to. It was different back then. But when he finally understood, he got an A in it. And he said, you just have to follow Jimbo. He's from Iowa. You just got to follow the rules. Oh, I've been telling you that for the last 3 years. Okay. Maybe I should have told you when you were drunk, but okay. So Friday is that last day. So if you need to know what your overall grade is right now, if you just want to be sure, again, it's just based on quizzes. Be happy to tell you during an office hour. Okay. I don't want, if you email me and ask me for a grade, like a PDF of your grade, that would be fine. However, please do not email me through Canvas. I will not send grades through Canvas. I don't want to accidentally go and you hit a reply all, or I hit a reply all, and all of a sudden everybody knows your business. So no Canvas with that. You will get a grade printout on Monday that reflects your test score, your homework score, everything. Okay. We're still trying to air. Solving linear equations. Linear equation is when we have x reversed. We're going to write this out step by step. Step number 1. You need to simplify both sides completely. Emphasis on the word completely. You got to simplify both sides completely. You don't start moving things left and right, getting numbers on one side. You don't start doing any of that until you've cleaned up each side individually. If you move from one place to another, you don't move individual items. You don't move individual books one at a time. You put all your books in one box. Put all the dishes, hopefully, in one box. But you gather all your towels or clothes, put them all together so you can move it all together. You clean it up before you move it. You want to clean up individual sides as best you can, everything you can do before you start moving things from left to right. Number 1, the left side is simplified because you can't combine 12x and 9, and that's just an 18, so that's simplified. But on number 2, we have some work we can do here on this one. We would distribute the 4 times x. 4 times -3 is -12 plus 3x. On this side, you can't combine, it's still 1 plus 8x. You finish simplifying this side. That's where that whole word completely. On this side, we have a 4x and a 3x. That's 7x minus 12 equals 1 plus 8x. as I'm doing the problem, going from left to right, looking for things that we can do, we can distribute the 4. And then right underneath it, write down what just happened. All I did was distribute the 4, and this is what we have. But bring everything down right underneath. And then the next step, let's see what else we can do. Now we're supposed to gather our like terms, simplify. I had to multiply before we could add. So I'm going to gather those two together. 4x plus 3x. They're on the same side. They're on the same side. I've seen this. I'm not going to go to the mistake that I see too often. I will once we get to the step 2. But they're on the same side. On the left, you have 4 x's, you have 3 x's. On the left, you have a total of 7 x's. Okay, clean that up before we start moving things left to right. 7x minus 12, you can't go any further. 1 plus 8x, you can't go any further. We'll take care of that in a minute. Simplify both sides. Step 2. Try to go with this order. Gather all your variables on one side of the equals. Gather your variables on one side. And get your constants, the numbers on the other side. Focus on the variables first. Because that's what you're solving for. We don't know what x equals. So decide which side you want to get your variables on. So let's write that out. Gather all variable terms on one side of the equation. Constants on the other side. Or constants on the opposite side. We're playing a little bit of checkers here, chess. You got to think through your moves. Have a plan. Decide before you make your move. On number 1, 12x minus 9 equals 18. We want all the variables on either the left or the right. Well, in number 1, there's only one term with a variable. Leave it alone. You don't want to move it to the right side because it's already, all the x's are in one place right here. So leave it there. So if I'm going to leave all the x's over here on the left, that means I need to take this constant, I need to take it over to the right. And the way we're doing step 2 is we're undoing addition or subtraction. That's how you move things from left to right in step 2. We want to undo. The whole goal is when we solve for x, we have to undo what's being done to x, so we just have one x by itself. So to undo this minus 9, we add 9 to both sides. So now we have 12x, negative 9 plus 9 is 0. So all you have left is 12x. And over here, 18 plus 9 is 27. Got my variables on the left, I got constant on the right. Okay. Now, leave a little room because there's a 2.5 right there. 2.5. Step 3. Now you undo multiplication. And or division. And I know you're going to hurt me. You're going to throw something at me. But there's a little extra something up there about number 1. I'll come back to it. Because I wasn't looking at the level of difficulty. There's going to be something we're going to put in there. 12 times x. So we want to undo multiplication. So we divide both sides by 12. So 12 over 12 is 1. So we're left with 1x, which is just x, equals step 4. You always simplify / reduce the lowest terms. Twelve and 27 have a common factor of what? Right. So this is 3 times 9 over 3 times 4. So we can reduce the 3's to get 9 over 4. Lowest terms. Now, for peace of mind, because this chapter is dealing with solving equations, how do you know before you walk out the door whether or not you have the right answer? Check your answer. You don't have to do this. Perfectly voluntary. You plug it in, check your answer. Plug it into the original question. 12x minus 9 equals 18. If we plug in 9 over 4, it's supposed to work. So 12 times 9 over 4 is minus 9, correctly making 18. How many times does 4 go into 12? 3 times. 3 times 9 is 27, minus 9, and makes 18. 27 minus 9, 18 over 18. So when I plug in that answer, if I get the left side and the right side equal to each other, it's the right answer. You could check it on a calculator that way. You could sometimes even plug it in your head, see if it works. But there's no reason to leave something that has no, possibly no chance of working. You get, let's say you get -2. If x is -2 and you just leave -2, I feel great. You're doing that Elon Musk thing where you're jumping up and down. Well, I don't work hard enough. But a negative times a positive, this would be a negative, and then minus 9 is a positive. There's no chance of working. So you don't even have to figure it out totally. You got a negative answer as soon as you see that has no chance. So don't just leave it, think about it. Over here, continuing on over there. I want to go back to variables on one side, constants on the other. Let me go backtrack. So what we did is we got the constants on the other, so we added 9 to both sides. And then we divide. Right here, this is what I see way too often. People get confused between step 2 and step 1. Step 1, simplify completely. So they distribute. And then they think they're in step 2, and they see this positive 3x and that 4x, and they do this. What they did was, here's equals. On the right-hand side, they subtracted 6x from the left, your left, sorry. From the left-hand side, they subtracted 6 x's from the left, nothing from the right. So it's no longer balanced. They took away 6 x's from the left-hand side and nothing over here. Whatever you do to the left, you got to do to the right to keep it balanced. So that's why step 2, when we say simplify completely, you're just combining your like terms. You're staying on this side.
4x plus 3x is 7x's, and then minus 12 equal that 1 plus 8x.
Okay. Now, we want to get all of our x's on one side. So think this through.
If I decide to bring the x's to the left, you would have to subtract 8x. So minus 8x, and over here, 7 minus 8.
7x minus 8x. What are we going to get? Negative x, negative 1x, which is absolutely fine. Just remember,
If I subtract 8x, 7x minus 8x is negative x. And then you take the constant to the left. Or if you want to avoid negatives, you could take the x's to the right side. It doesn't matter, you just need to make a choice. If I decide to take x to the right side, subtract 7x from both sides, this cancels out. I have a negative 12 equals 1. 8x minus 7x is positive 1x, or just plus x. So we can compare it. And we can see that it doesn't matter. You just have to be careful with your signs. If we bring it to the left, we would have subtracted 8x from both sides. 7x minus 8x is negative x, and then a minus 12 equals 1. Okay. So if I'm solving for x, I get my x's on the right, so I'm going to take this constant, I'm going to bring it over to the left. To undo a positive 1, we would subtract 1 from both sides. Negative 12 minus 1 is negative 13 equals x, or x equals negative 13.
at the bottom of the box, x, x equals is waiting for you.
Over here, negative x minus 12 equals 1. So I got to take the 12 to the right. How do I undo a negative 12? Add 12. Just don't forget, this is negative x equals 1 plus 12, which is positive 13. Over here, we were done because we have x by itself. The third step is undo multiplication and or division. Well, we don't have anything multiplied times x, but here you'll do. We don't care at the bottom of the box. It doesn't say what is negative x equals, what is positive x equal. This is negative 1 times x. That's how you get negative x. So to solve for x, you divide both sides by negative 1. Negative x divided by negative 1, that's how we change it to positive x. And 13 divided by negative 1 is the same answer, negative 13.
So it doesn't matter. You just have to pick, and you got to keep track of your signs. Doesn't matter. It's on you. I don't know which side to take it on. Pick one. Which one should I do? I don't know. Which one do you like? Have you thought it through? Well, just pick one and go with it. Pick one and go with it. Otherwise, if you don't move forward, you're never going to get anywhere. Okay. Number 3. Step 1. Simplify both sides completely. So on the left, we have a lot of distributing and combining like term things. So in the parentheses, you can't do anything with a 4x minus 2. You can't do anything with 5x minus 8. So we're going to distribute this 3.
3 times positive 4x, that's 12x. 3 times negative 2 is minus 6. And then minus this parenthesis. When you subtract the parentheses, the negative will distribute and change those signs. If you have a positive in here, it comes out a negative. If you have a negative, it's going to change to a positive. Because what you actually have, that minus this parentheses, is exactly like having -1 times the parentheses. So when you distribute it, it's -1 times that positive 5x, so now it's negative 5x. And it's -1 times that negative 8, and that's now plus 8. Keep going from left to right. Finish the right side. Don't start going down here and start working this. Forget about doing that. If that becomes an afterthought, that'll get rushed. Just work the problem from left to right, then bring it down top to bottom. Over here. Do I distribute 8 into the parentheses? No, because it's addition. Just because you see an 8 and then parentheses, it's not times. It's a plus. Okay, so don't do something that's not there. So you can't do 2x minus 3. So bring down the 8. If it's addition, the signs don't change. Plus a positive 2x is still plus 2x. Plus a negative 3 is still minus 3. But the parentheses are gone. Okay. So now we keep going from left to right. Over here, combining like terms. Positive 12x minus 5x. 12 minus 5, that's 7x. Negative 6 and a positive 8. Negative 6 plus 8 is a positive 2. Equals. On the right side, you got a positive 2x. And then a positive 8 minus 3. 8 minus 3 is a plus 5. Look at the mess that started. Now look at what you're working. If you do step 1 and simplify completely, it cleans it up really nice. Then you pick side. Get all your variables on one side. So we either subtract 7x from both sides, take it to the right, or we subtract 2x from both sides and bring it to the left. So are we going to bring it to the left, take it to the right? Bring it to the left. So we would subtract 2x. 7x minus 2x gives us 5x, and then a plus 2. And we're there, you get a 5. And then since the variables are on the left, you're going to take the constant and take it over to the right. Since that's positive 2, we're going to subtract 2. And we got 5x. 5 minus 2 is 3. So now all we have left is multiplication. Undo multiplication, divide each side by 5. Simplify your answer, reduce it to lowest terms. There's no common factor, that is lowest terms. The age-old question that a math teacher would usually get is, when am I ever going to have to use this? And so we say, all right, well, look at this word problem where we set this thing up. We're dealing with area, we're dealing with perimeter, we're dealing with cost versus revenue, or we're dealing with velocity. I don't want to do more. I don't like it. But you wanted to know when we could use it, how it fits. Construction, look at these triangles and sizes and shapes and how these things. I don't want to do this. But you just ask them. The way you work these problems is to take life and make it into an equation that is solvable. And in order to solve an equation, you have to have unknowns. And the way you represent those unknowns is with variables. If you could write an equation and have a variable in it, then you have all the tools you need to solve. The question is, how do we write the life experience into an equation? Well, a lot of that's already been done for us. We just need the tools to know how to work the equation and solve it. And you do it one step at a time. These are the basic ones. Linear, x to the first. Then 2.4, we do x squared. Follow it up with the rest of them. Okay. Number 4. 2x plus 2x minus 9 equals 2 times x plus 3. $16x plus 4 times 3x minus 2. 7 equals 22. 15. All right, step 1, simplify. On the left, 2x minus 5, can't do anything with that. On the right, distribute 2. So 2 times x is 2x. 2 times 3 is a plus 6. So simplify, that's done. Let's get all the variables on one side. So just pick a side, left or right. Left. So if I bring this 2x to the left, I would have to subtract it. And here's where your brain has to go, wait a second. On the left, 2x minus 2x is what? 0. So what do I write? Nothing. There's nothing there. I still have -5 though. Equals 2x minus 2x. That's 0. It cancels out. What do I have left? I have 6. So here's the deal. I have the same amount of x's on both sides. So it doesn't matter which side I would have taken it to. It's always going to cancel out. X doesn't matter. There's no x left to solve for. Whatever I plug in, it's always going to cancel out. So here's that 2.5 step. So when you do step 2 and you get all your variables on one side, if the variable cancels out, you need to check the leftovers. You look at what you have left over. We have -5 equal to 6. There's going to be 2 possibilities. Either the leftover term is a false statement or it's a true statement. Either what we have left over is false or it's true. Is this true or false? That's false. -5 does not equal 6. That's false. If the leftovers are false, then X equals the words no solution. The equation has no solution. There's nothing. There's absolutely nothing I can plug in for X that's going to make it work. Because whatever I plug in is always going to cancel out anyway, and I'll always be left with a false statement. So you write the two words, no solution. Please do not put this. Well, actually, you know what? I take that back. Some of you write zeros like this. For whatever reason, you've been taught to write zeros like that. I know in the past somebody has told me in the military, they're told to write their zeros like that, so they're not confused with those. However, in mathematics, that is not a zero. That is the symbol for an empty set. It means something completely different. It doesn't mean zero. So if you put zero, you're saying the answer is zero. Zero, plug it in, and it works. Technically, the answer would be the word empty set because there's nothing in the set of answers. But I want to avoid all confusion and just say we write the words no solution. It's false. They got different choice. If the leftovers are true statement. And I have an example of that. If the leftovers is true, then X equals all real numbers. No matter what you plug in, everything works. There's an example of that. So number 4, X is number 5. A lot of simplifying. So we start left to right. In the parentheses, you cannot do anything with 3x minus 7. So that's right, 16x plus 4, they're not like terms. And you'd have to distribute the 4 anyway. You have to do this first. 4 times 3x minus 7. So we bring down the 16x. Positive 4 times positive 3x, that's positive 12x. And then positive 4 times a negative 7, that's minus 28. Equals. What's 12 minus 2? Not here. I can't subtract 12 and 2 because order of operations. I have to multiply before I do the subtraction. I have to multiply, unless you have to multiply into the parentheses before I can subtract. You can't do anything with 15 minus 4x. You do not want to subtract because you have to multiply first. So you bring down the 12. Negative 2 times 15 is negative 30. Negative 2 times negative 4x is positive 8x. Don't try to take huge bites out of this. Just one little tiny bite at a time. All I did was distribute into the parentheses. Still doing step 1, combine like terms. So we have on the left side, I have 2 terms with an x. 16x plus 12x, that's 28x. And a minus 28 equal to, on the right side, I have 8x. And then 12 minus 30. So 12 minus 30 is negative 18. Any problem there? So all of that was just simplified. Step 1. And look how cleaned up it is. It's two terms, you got two terms. So now when you decide to take your x's to the left or to the right, do we want to subtract 28x from both sides, or do we want to subtract 8x from both sides, bring it over to the left? So let's subtract 8x from both sides. 28x minus 8x is 20x minus 28 equals negative 18. And then add 28 to it. 20x is equal to negative 18 plus 28 is positive 10. So now you have multiplications. That's all you have left. So to undo multiplication, we divide both sides by 20. All right. 10 over 20, reduce it. 1/2. Number 6, simplify both sides. So we distribute this 2 times x, 2x, 2 times 3 is plus 6 equals 2 times x is 2x, 2 times 4 is plus 8, minus 2. So we keep simplifying. We got 2x, still plus 6. Over here, what do we end up with? 2x plus 8 minus 2. 2x plus 6. So there's my 2x, and then 8 minus 2 is a positive 6. So when we decide to take 2x out, it doesn't matter. Let's take it to the right. It's still going to cancel out. But look at the leftover. This time, we end up with a true statement. So the variables cancel out. So no matter what, doesn't matter what the variable is, it's always going to cancel out. So what we have left over is true. If the leftovers are true at the bottom, the answer is all real numbers. Every or any value you could possibly think of would make that work. Everything. So true versus false if the variable cancels out. I wrote number 5 twice. There's something wrong about that one. Okay, number 8. Number 7. Okay, yep. Number 8. 0.42x. But 0.17. 2x plus 3 is equal to 2.2. Well, it's 2 times 2.5. Minus. Okay. Round your answer to the nearest hundred. That means you use a calculator and you want to make sure that you know all the way out to at least the nearest thousand. Never round the problem as you're doing the problem. You need as many decimals as you're working at, so you have all the information you need to round it correct. So from left to right, you can't combine 0.42x with 0.17 equal distribute. So 0.42x positive 0.17 times 2x. That's a positive 0.34x. And then positive 0.17 times 3 is a positive 0.51 equals 2.2. Distribute the 2. 2 times 2.5x is plus 5x. 2 times negative 5 is minus 10. So we keep simplifying. 0.42x plus 0.34x is equal to 0.76x plus 0.51 equals, we have 5x. And then 2.2 minus 10 is going to be negative 7.8. And okay. So everything is simplified. Left side, right side, go simplify. So now you make a choice. We either bring the x's to the left or take it to the right. If I bring them to the x or to the left, you're going to bring 5x and subtract 5x from 0.76. That means think about decimals like money. 76 cents minus $5. The answer is going to be negative. Or you can subtract 76 cents from both sides. $5 minus 76 cents, and that might be easier to deal with. So you make a choice. I'm going to go ahead and take it to the right. I'm going to subtract 0.76x from both sides. So I still have 51 cents equal to $5 take away 76 cents is $4.24 times x. 4.24x. And I still have minus 7.8. So since I took the x's to the right side, I got to bring 7.8 over here to the left. I'm going to add 7.8. And over here, we're going to get 8.31 equal to 4.24x. So simplify both sides completely. Get your variables on one side. Focus on the variable part first. Variables on one side, then the constant on the other side. Separate the variable from the constant. Now we're going to undo multiplication or division. This is 4.24x, so we divide both sides by 4.24. This is where you punch it in. This is where you have to go around correctly. 8.31 divided by 4.24. So we end up with x equal to 1.9599056, but to the nearest hundredth, a hundredth of a dollar is a penny, and that's that 5 right here. This 9 rounds that up to a 6. So x would be approximately 1.96. So number 9, and then we'll do last night's announcement problem. The bonus clue that I put in the announcement problem, this one. So if you haven't opened up the announcement I sent, it's got clues about what's the bonus is going to be like. And the last one is solving something that looks like that, which is just the equation that has fractions in it, which is just like number 9 here. It just doesn't have as many terms as that one in the announcement. You're going to do it the same way. So I'm going to write this one down. I still have it. I'm sure the projector will kick out. So I told you there's a little extra on step 1. Simplify both sides completely. Undo fraction. If you have fractions, undo the fractions. And the way you undo fractions is you multiply every term by the least common denominator. Multiply all terms by the least common denominator. Because the problem is, it's the denominators that are causing the fractions. So we want to undo the denominators. Denominators mean division, so if I multiply, it'll undo the denominators. So I need a number that's going to undo a 4, a 5, a 2, and a 3. Well, if it was just, let's do this. No, make a list. If it was just a 4, a 5, a 2, and a 3, if it was just a 4 and a 5, the first number that 4 and 5 both go into is 20. If it was just a 4 and a 5, I could use a 20, and it would undo the 4, and it would undo the 5. But, 2 also, so 20, a 2, and a 3, a 20 and a 2. 20 would also undo a 2. If I multiply this by 20, 2 goes into 20 even. Works out. But the problem is, if I multiply 4/3 by 20, 3 doesn't go in 20 even. So now I'm just, you need something that's 20 and 3. What would they go into even? The only number that 20 and 3 go into evenly is now a 60. That's the least common denominator for those 4 fractions. For a 4, a 5, a 2, and a 3, it's a 60. That's the smallest number that will undo all of those fractions. Least common denominator. Okay. 20 then does the 4 and 5, but it's not going to undo the 3. If I just focus on the 2 and the 3, if it was just these, I would use a 6. But a 6 does not undo a 5 or a 4. Well, a 6 and a 5, I could use a 30, because a 30 would undo a 2, 3, and a 5. But 4 doesn't go into 30. So what's the next number? Well, the next number of 30 would be 60. 4 goes into 60. You got to find the number that all of those denominators are going to get canceled with. The first number they all go into even. So I just listed all 4 of them. Take 2 at a time. What works for those 2? Now, here comes the 2 that wants to play along. Well, I don't have to change anything because 2 and 20, 2 will go in 20 units. Now, what about the last one? Now I need a bigger number. But I'm not trying to look at all 4 all at once. I just look at 2 at a time. So the least common denominator here is 60. And everybody's going to get multiplied by 60. So this one times 60. This one times a 60. Times a 60. And this one times a 60. And the whole purpose is to undo the fractions. This 4 goes into 60 15 times. I'm left with 15 times 3, which is 45x. Minus 5 goes into 60 12 times. I'm left with 12 times 2, so that's minus 24. Equals 2 goes into 60 30 times. I'm left with 9 times 30, which is 270x. It's just what it is. Plus 3 goes into 60 20 times. So 4 times 20 is 80. No more fractions. Simplify both sides completely. Well, there's nothing else I need to do to simplify it. Everything's gathered, all the x's are all gathered together. All over here, like terms are gathered up. So now just pick which side you want to take x to. We either subtract 45x from both sides or subtract 270 from both sides. So do we take x to the right or bring it to the left? So subtract 45x. And we have negative 24 equal to negative 270 down positive 225 x plus 8. If we do that, we're going to bring 80 to the left, subtract 8. Negative 24 and negative 80 is a negative 104 equal to positive 225x. Divide both sides by 225. So x is equal to negative 104 over 225. You always got to reduce it. Now, here's what I know. That's done. Okay, because 225 is 15 times 15. Well, 104 is even, so I can't divide by 2. The only thing going into 15s are 3 times 5s. It doesn't end into 5. And the sum, 1 plus 0 plus 4, the sum does not add up to a number that's divisible by 3. So this is not divisible by 3, so I can't, I'm not gonna be able to reduce anything. That's the lowest terms. X equals negative 104 over 225.
So if you're doing the chapter 1 bonus quiz, bonus problems, you got something that looks like this over here.
So I see denominators that I want to get rid of, want to undo. So I can have to deal with fractions. So I'm looking at, I got 9, I got a 15, I got a 4, I got a 3 and a 10. 9 and 15. $45. The first number that 9 and 15 both go into is 45. Okay. And then here comes the 4, the 3, and the 10.
4, 45. Well, 4 times 45 is the smallest one you're going to get.
Okay, 4 times 45, so that's going to be 180.
Now, here's the good news. 3 goes into 180.
The smallest number that 180 and 3 both go into is 180. And the smallest number that 10 and 180 will go into is 180.
So the least common denominator is 180. Okay.
But again, I'm just looking at 2 numbers at a time. First thing that these 2 go to, 45. Well, 45 is made up of 3 times 3 times 3 times 5. 4 is 2 times 2. They have nothing in common, so it has to be 45 times 4. 180. 180 has a 3 in it. So I don't need anything but the 180 because it already has a 3 in it. 10 is 2 times 5. 180 has a 2 and a 5 in it. So I don't need to change 180. That's why he's common. Everybody gets multiplied by 100. Nine goes into 180 20 times. 8 times 20 is 160. Minus 15 goes into 180. Let's see. 36 times. Yeah, 36 times. 36 times. And then you have plus 4 goes into 180. 45 times. Oops, 45 times 7. Actually, I'm already messing this up. 15 goes 180, 36 times. I'm looking at 36 times 14. X. I'm going to write it out. And then I'm left with 4 goes into 180, where we have 225 times. No. $45. 3 going 160 times. 10 goes to 180, 18 times. So 18 times 3, don't forget the x. Minus 4 times 100. No more fractions. Are you okay with what I wrote down here, 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 here? About what we have left over. Well, yes. Okay. 160 minus, let's see, and we're 360 and 504x. 315. 654x minus 704. Somebody check those for me. 336 times 14, is that 504? Okay. 45 times 7, is that 315? And I'm pretty sure 60 times 7, 600. 18 times 2, okay, that 4 times down. Okay. Then we have x's negative 504. 160 and a positive 315 is going to be a positive 475. Into 54x. 600 minus 720 is negative 120. There's my x. Thank you very much. I'm almost gonna hit a mental wall. All right, so we either take x's to the right, add 504 x to both sides, or we subtract 54x and bring it to the left. So what do we want to do? X on the right or left? If I bring it to the left, it will be negative, which is fine. Keep track is negative. But if I add it, I'll end up with a positive amount. And it, again, won't matter. But most of the time, people prefer positive. 475 equals 558 minus 120. Let's add 120. So that is equal to 595. Equal to 558 x. And it will not reduce. So we divide both sides by 558. X is equal to 595 over 558. Now, the reason why I know that it won't reduce. This is what it equals. This is 5 times 119. And 119 is not going to factor. So there's nothing I can get that will reduce 595 and 558. So that's like your bonus budget. No more of those. So it kind of covered basically all the notes. Let's just kind of apply it to the home. I did email and post the assignment sheet. Here's copies, tabs them around, take one, no. If you notice, the first example I have up on the board to do is 26, which I did. It was the second one that I had on the board as an example. Here in the book, 26 is 4 times z minus 3 plus 3z equals 1 plus 8z. I just put x's instead of z's. So we technically did that one. $32 fractions. 3x over 2 plus 1/4 times x minus 2 equals 10. 34 x minus 11 over x equals x minus 9 over x. And then plus 2. And if you notice, 39, then 36. Now, there's a reason. So, my first question for this. On number 32, on the left-hand side, how many terms are there? Because we always want to simplify both sides, combine like terms. On the left-hand side, how many terms do we have right now? 2. There are 2 terms. This is 1 term. This right here is 1 term. There's lots of things in it, but because it's multiplication, this is all just one thing. This one plus this one. If I distribute, don't do this, just watch for a second. If I bring this down and I distribute 1/4 times x, 1/4 times -2, now I've got 3 terms if I distribute. What would be the next thing is undo the fractions. But technically, it might be easier if I just look at this as 2 terms, they have fractions. Fraction, fraction, no fraction. What's the least common denominator for these 2 fractions? What? To undo a 2, I need a 2, but 2 does not undo 4. To undo a 4, I need to multiply by 4. And if I multiply by 4, it undoes the 2. The least common denominator is a 4. So I'm going to multiply every term. Now there's 3 of them, that make sure you do both sides. Everybody gets multiplied by a 4. When I say everybody, I mean each individual term. Remember, on the left-hand side, there's only 2 terms. 2 goes into that 4 twice. I have 6x plus. Before I can even distribute, 4 goes into that 4 evenly. I have a 1 left over, so I have 1 to distribute. I don't distribute anything. It just undid the fraction. It's just x minus 2 on the right side for it. I undid the fraction before I distributed the fraction. Six x plus one x and 7x minus 2 equals 40. We'll add 2. And then we get 7x. 40 plus 2 is 42. Undo multiplication, divide by 7. And x is equal to 6. And the original problem was 3x over 2 plus 1/4 times x minus 2 was supposed to make it 10. So if I plug in 6, 3 times 6 over 2 plus 1/4 of 6 minus 2 is supposed to make it 10. What's 3 times 6? 18. What's 18 divided by 2? 9. That's 9. Plus, what's 6 minus 2? 4. What's 1/4 of 4? 1. What's 9 plus 1? So I plug in 6, it makes the equation work. Okay. You're supposed to undo what's being done to the x, so you know that you have right or wrong, plug it in and see if it worked. Now, 34 is a little bit of a curveball because it's not a number down there, but it's still a denominator. To undo those denominators, what would you multiply by? An x. I want to undo the denominator, so to undo divide by x, I multiply by x. That's the least common denominator, is x. Because I don't want fractions. The least common denominator, everybody's going to get multiplied by an x. So this one is going to get multiplied by an x. This one is going to get multiplied by an x. And don't forget this term. All the terms get multiplied by an x. So the whole purpose is to undo the fraction before you multiply. X divided by x reduces. All you have left over is that x minus 11 equal to this x over x reduces. All you have left over is that x minus 9 and then plus the 2x. No more fractions. So step 1, undo, simplify, undo the fractions if necessary. We undid the fractions, but it's not simplified yet. We can combine some like terms over there on the right. The left side is good, x minus 11. But on the right, what is x minus 9 plus 2x going to be? 3x. 1x and 2x, 3x, and a minus 9. So simplify both sides completely. Done. Step 2. Focus on the variable curves. Get your variable terms on one side. So we either take the x's, subtract 1x from both sides, or subtract 3x from both sides. So take it to the left or take it to the right. Or if you're the Doobie Brothers, you'll take it to the street. To the right. So we're going to subtract 1x from both sides. So we're left with a negative 11 equal to 3x minus x, positive 2x, and minus 9. So since we took and gathered all the x's on the right, we're bringing the constant to the left. You have to add 9. Negative 11, keep track of your signs. Negative 11 plus 9 was negative 2 equal to 2x. So now you would undo multiplication or division. So this is multiplication divided by 2. What's negative 2 over 2? So final answer is negative 1. And let's see, x minus 11 over x is supposed to equal x minus 9 over x and a plus 2. If we plug in a negative 1, negative 1 minus 11 over negative 1 is supposed to equal negative 1 minus 9 over negative 1 and a plus 2. So negative 1 minus 11, this is negative 12 over negative 1. This is negative 10 over negative 1 and then a plus 2. What's negative 12 divided by negative 1? Well, yeah, positive 12. Negative 10 divided by negative 1 is a positive 10 plus 2 and 12 equals 10.
If you know you work those steps exactly the same way every single time and you're getting the right answers all the time, I would be really confident about winning the test because it just becomes that muscle memory. It's not going to change on us. Okay? Nobody's going to come around and invent some different way where the answers come out differently. One step at a time. $39 versus 36. They're both dealing with fractions. One comes nice, one comes not. I wish they would have put it in a different order if they did. $39. And I'm just going to talk you through it. 39 says something. And we'll focus on it. 2 over x minus 4 times x minus 2. That's equal to 1 over x minus 4 plus 2 over x minus 2. And at 36, not so kind. 1 over x minus 2 plus 3 over x plus 3 equals 4 over x squared plus x minus 6. So obviously we have step 1 simplified and we have fractions. We want to undo the fractions. On 39, I would want to undo, if this was, let's say 2 over 15. And over here, you had like 1 over a 3 and a 1 over a 5. Well, 15 has 3 and 5 as factors. That's what makes 15.
So the least common denominator that undoes the 15, the 3, and the 5 is 15 itself. 15 undoes this, it undoes each one of those individually. Which, if you look at the choices that they gave in number 39, if I multiply, in order to undo this one, I would have to multiply by an x minus 4 and an x minus 2 to undo all of that, which means everybody gets the same treatment, x minus 4 and an x minus 2, an x minus 4 and an x minus 2. Here, all I have left is a 2. But over here, the x minus 4 reduces. I'm left with 1 times x minus 2. And over here, the x minus 2 reduces, and I'm left with that 2 times the x minus 4. Number 39 is given to you, where you obviously can see what you need to undo the denominator. I need these factors. I need an x minus 4 and x minus 2, which is convenient because I have an x minus 4, it will undo that one. I'll have an x minus 2, and it will undo that one. So that's my least common denominator. It's x minus 4 times x minus 2. And it's right in front of my nose. Number 36, I don't know why they go backwards with this, but I think it's because they expect you to actually know how to factor. Which I know some of you treat that as like a 4-letter F word, even though it's a 6-letter. I will be reviewing factoring in the co-recs. So factoring is an issue for you. You might want to watch the co-rec, either come to the co-rec or watch the co-rec when we actually do it, watch the co-rec videos. I need to undo an x minus 2, so I'll have to multiply by at least an x minus 2, and I'll have to multiply by an x plus 3 to undo these denominators. I hope that will undo x squared plus x minus 6. That's only if this factors and equals these two multiplied together. So if you know how to factor this, first times first has to be x squared. It has to be x times x. Last times last is negative, so it has to be a plus and a minus. Last times last is 6, so that could be 1 times 6 or 2 times 3. So if I try 1 and 6, that's not going to make 1x in the middle, but it's not going to be 1, 6. So I try 2 and 3. If I go 2 here and 3 here, x times negative 3, that's negative 3x. 2 times x is positive 2x. That's negative. I don't want negative, I want positive 1. So all I got to do is change that to the minus, change that to the plus. Oh, isn't that nice? It's the same backwards. This is 4 over x minus 2 times x plus 3. Conveniently. So the least common denominator, just like this one, where it's given to you, is going to be these two factors. Just given to you. So you're going to multiply everybody by those and you solve. We have left over. So even if you don't know how to factor, guess what the factors will be? Those two multiply together. Okay. So we'll continue on there on Monday. I'm not going to give you the quiz round until Monday, and then we'll move the quiz to the following. Okay, so.